Hello, everybody, and welcome back to another lesson in contemporary math. This lesson will be over section 6A. We will be characterizing data in this particular lesson. And what that allows us to do is look at data distributions and try to interpret them a little bit better. That is looking at graphs of data and trying to interpret them a little bit better. And then we will look at measures of central tendency, things like an average, aka mean, or a median, or a mode, and how they are affected by outliers, and which of those, mean, median, or mode, is best to use depending upon given situation. Let's jump right in. We have frequency tables. Now, frequency tables are not anything new. They're just bar graphs. You can see a couple examples down here. They show us how data is distributed. This sometimes is referred to as the shape of the data, or, and this is the important one, the distribution of the data. So for the following two data distributions, which do you prefer as a student? Well, if you take a few seconds to look here, and here, you can tell that more students got A's in this course than in this course. In fact, 9 students got A's and only 4 students got A's over here from Miss Clark. The B's were even less than this. There were 7 B's here and 5 B's here. Now there were way more C's. There were 8 here and 5 here, and then you can compare D's and F's on your own here too as well. So I've labeled down here very quickly how many of each grade were given out for each course. Now, if you were a student looking at this, I'm like 99% sure you would pick this one, because there are 21 people out of 24 total that would pass. So you could say this would be an easy pass. But an easy pass is not always a good thing. You may want to actually fully understand the material that is being taught in a math course. And so while this one on the right, Miss Jones's class, may be an easy pass, you may actually learn more for this course. And this may end up having a better teacher. So Miss Clark's algebra class may have been better off and better prepared for the real world and the next math course just based on looking at this data. All right, so let's look at some measures of central tendency, and maybe we can get a better idea for how this will work. So we have an average is a measure of central tendency for a set of numbers. 3 commonly used measures of central tendency are mean, that's average, what we call average, median, and mode, and we will go over these two in a little bit. So the mean. To find the mean of a set of data, add the data and divide by the number of data. This is the concept of average that we are most familiar with. So when we do this, we find the mean of the test scores over here. And all we have to do then is we have to add, that's 19 plus 24 plus, we just take all of these numbers and add them together. And then we divide by the number of numbers. So when we do something like that, we count 1, 2, 3. I've got 8 total numbers here. So I'm going to divide by 8. So when you add up all these numbers in the top, you will get 544. Then you divide by 8 and get a whopping 68. Do you think that's a pretty good average for a set of exams? I don't think so. So why is this average so low? Does that mean the entire class did horribly bad? No. If you take a look at these two numbers here, 19 and 24, These are what we call outliers. These numbers are very, very far from our average. 19 is a pretty low score. That normally doesn't happen. Same thing with the 24. And these numbers, these outliers in this case, bring the average down. So AVG is just an abbreviation for average. So I point this out because the mean is the most sensitive measure of central tendency. It weighs each piece of the data equally. So that means it is going to be the most affected by a really low or a really high score. All right, so let's take a look at median, a different way to average things. So a median for a set of data that is ordered, and that is super important. They have to be in order, smallest to biggest, is the middle value or the mean of the middle two values. So what do those last couple phrases mean? The middle value, if you have an odd number of numbers, and the mean of the middle two if you have an even number of numbers. And I'm talking how many numbers are in your list. So if you take a look at the first example here, I have 5 numbers here. They are all in order. 16 is the smallest number in this list, then 18, 19, 22, or 20 and 22. They're all in order. Since we have an odd number of numbers, we just have to pull the middle number to be the median. The middle number here is 19. So the median is 19. For this other example over here, we have 1, 2, 3, 4, 5, 6, 7, 8 numbers. And that means we have an even number of numbers, like we do over here, like what I said. That means we have to take the mean of the middle two numbers. So what that will look like is we will take 74, we will add 82, and then we will divide that all by 2. So 74 plus 82 is 156. 156. And when you divide 156 by 2, you will get 78. And that is your median for this list of numbers. Now, why is it important to know the difference between these two? We'll get to that on the next slide. All right, for this example 4, you can see we have salaries for the workers in a small company. We've got 34,000, 22,000, 240,000, 42,000, and 30,000. So we are asked to find both the mean and the median of these salaries. Well, I'm going to put them in order for you, and then I'm going to let you have a few seconds to pause the video and find the median and mean for yourself. So this is one of the first things you need to do if you're trying to find a median is put them in order. Then you can go on and find the median and mean. So go ahead and pause the video and give that a shot. Since there are only 5 numbers in our list, that is an odd number of numbers. What that means is we can just take the middle number, and that's our median. Median is 34,000, and in fact, dollars. I should probably be using units for all of these. Let's see here. So dollars. All right. The mean, on the other hand, you have to add up all of these values. So you can add up 22,000 and 30,000 and 35, all those values, and you'll get 368,000. You'll divide it by 5 because that's how many numbers are in the list, and you'll get $73,600. Now, the question: which measure is the best measure of average for the data? And honestly, it depends on who you are. If you are the business, you probably want to be using this one here, $73,600, because you can advertise out to hiring websites and whatnot, hey, our employees make $73,000 on average. But if you're the employee, if you're a potential hire for this company, you want to know what the median salary is, because that's probably closer to what you're going to actually be paid. You see there are 4 salaries here, $22,000, $30,000, $34,000, $42,000. They're all less than $50,000, and you've got one hot shot over here making $240,000 a year. That's just one person, though. That may be the owner who puts in all the work and takes all the profit. And so you can see which measure is the best measure of average for the data. I'm going to say the median here, because that more accurately represents the data that we have available to us. But in the real world, it depends on who you're asking. But for the purposes of this example, we're going to say median. Again, it more accurately represents the data that we are given. So one thing that you'll want to be sure is, for finding the median, is you want to be sure the data is ordered. I did that for you. You're going to have to do that yourself at some point before locating the middle number or the middle 2 numbers to find the average. That being said, the median is not affected by extreme values, aka outliers. Outliers don't affect the median as much. With that being said, the salary $240,000 in this set of data is what we call an outlier. An outlier in a set of data is a data value that is much higher or lower than most of the other data. So for our final examples in this video, we're going to talk about the last type of average here, and that being a mode. And the mode is the piece of data that occurs the most frequently. Which number comes up most commonly? In fact, the mode, and I missed this in the previous 2 examples, the previous 2 examples are quantitative ideas. Finding the mean and finding the median, you have to have numbers in order to make that work. Whereas if you have a mode, that can be used for quantitative data and for qualitative data. So you can think of a scenario where maybe somebody in the Houston area is trying to find out what is the most popular make of car. Is it Ford? Is it Acura? Is it Honda? Is it Lexus? What's the most popular make of car? Someone could go to a parking lot and just walk around and count which happens most commonly, which happens most frequently. That would be finding a mode. But it doesn't have to be numbers. Although in these next 2 examples, they are numbers. So here we go. I think it's easier to do if you have a list of numbers that is ordered. So you can see, for example, 5, this list is already ordered. We have 8, 8, that's 2. We have 10, 10, 10, that's 3. We've got 12, 12, that's 2. And we've got 14, that's 1. So which one happens the most frequently? It's a pretty simple answer. 10 is our answer. That is the mode. Like, that's how easy it is to find a mode. But when you look over here at something like example 6, after I put them in order, you can see that we have two different values here that are showing up twice. Everything else only shows up once. Well, what are you supposed to do here? If that happens, if you get more than one value that keeps showing up the same amount of times, well, that just means we have something that is called bimodal. Bimodal. Two modes. So we can have more than one mode, and that is absolutely fine. We have a mode of 1 and 4. If you go back to the parking lot example, maybe there are the same number of Chevy trucks and Dodge trucks. It happens, so there's a tie. So there are absolutely bimodal ideas that happen out there in the real world. So here we have, lastly, some common frequency distributions and all their names and what the graphs would look like. So with this one, the rectangular distribution, another way to say this would be uniform. It's the same all the way across the board, as you would say. It looks like a rectangle. If it's uniform, everything is the same. We have a J-shaped distribution. I don't know, maybe you can see it like this. And it can be a backward J. Put a little cap on it, there we go. We have the aforementioned, again, not that long ago, the bimodal distribution, where we have two very common occurrences of some values, and the rest of them are not common at all. We have this. These two down here are related to each other, skewed to the right, skewed to the left. And we have what we call tails. So you can see this would tail off to the right, and this one would tail off to the left. So that's how you can keep those straight. And then this one here we have is called the normal distribution. And it is what we would say symmetric. So it's symmetric around the middle value. And we're going to get more into this in successive videos, but that middle value we're going to call the mean. So it is symmetric about the mean. Just doing a little foreshadowing there. And that's it. That concludes the lesson for section 6A, measures of central tendency and analyzing data. Good luck.